the straight branch. So the power's on either one side or the other side, depending on which way this arm is set to.
Hello, I'm James Ingram. This video was digitized from a 1992 videotape series named V9202.
Now, as we hook this thing up to AC power, and this has the same old Radio Shack RCA phono connector as the blocks do, so you can make quick AC power connections without a screwdriver or anything. As we hook up this AC power, we should see the indicator light coming on to indicate that we're getting AC power to this unit. That's not quite correct because I got the knife switch open. Now the AC power is hooked up. Now as I close that knife switch, I think does it show up? Yeah, I think you can see it in the picture that right where my finger is there. That light goes on and off. That light simply indicates this unit is getting AC power. And one capability this unit has, if you turn the power off, like if I disconnect it like that, whatever position these switches are set in the case it's set for straight right now, it'll act essentially like a piece of straight track. Trains will just go right on through the thing. So you can actually park a train on one of these legs. Like say if we wanted to park a train on this branch to take cars on and off the track, we can depower it as it is now, make sure the switches are set for straight, and all the trains passing by will just continuously go down the straight branch, and we can work on this train. And whenever we're ready to have this train pull out, then we can power this thing up, and the next train that comes in will flip the power over here, and this train will take off. I'm going to use a magnet to activate the two track contacts, and we should be able to verify that the AC power is working on this unit. You can't really see the motors too well, so what I've done is I put these little pieces of paper on the arm of the switch motor, this one up here, and a piece of paper back on the arm of the switch motor back here. So I think you can see, if you watch closely, hopefully, the arms of the motors moving. Let's see, the thing is set for straight presently, so this one here should actuate it to curved. And if you watch closely, you can see that arm moves over toward me, and this switch, it went that way, which set it to curved. Now if you manually activate the other track contact, this switch will go back to straight, which means that arm will come out toward me, and this motor will go that way. Just do it a few times. Let's put it back in the straight position. So what happens, the thing is set for straight right now. Basically the way this thing is wired up here, when the motor is over pointing this way, when the motor is toward this side, I've wired it so that it's putting power to this block. When the motor is to the left, it'll put power to this block. In other words, just to make it easy to remember which way is which, whichever way the arm is pointing is the side that the power will be applied to. So right now the thing is in the straight position. So if a train came from the rear and entered the switch unit, it would be directed down the straight branch. It would go over this track contact, which would throw the switch to curved and shift the power over to this side. So this block is now dead, so this train would roll up here, hit this dead block, and stop. The next thing would happen is another train would come along. Since the switch is curved, it would just come in this way. And you have to use your imagination, by the way, and pretend these two are connected. I've, again, taken the liberty of scrunching these together just so I can fit it all in the camera. But the train would come in the curve switch, come over this track contact, and throw it back to straight, which will shift the power over to this block. At that point, this train sitting here would take off. This train would continue on until it got to the dead block, the now dead block, and it would stop. Since the switch was set to straight, the next train that came along, third train in this scenario, would come down the straight side, go over this track contact, which would throw the power back to this side, which would start this train, and that train would die over here, and on, basically a flip-flop operation, which we'll demonstrate in some film later. we put some engines on the track to demonstrate how the power is flipped from one side to the other. You can't see it in the camera, but I've got a little binder clip attached to the rail, so these engines won't go anywhere. They're just going to sit here and spin, but it'll hopefully show how the power is either on one side or the other side. And I'm up ahead of the block here off the camera, but to the as you're looking at it to the left, I'm feeding track power right in here. You can see currently the power is on the straight section there. Now keep in mind, normally both trains wouldn't be sitting here at the same time. Normally one would be here and the other side would either be empty or there'd be a train pulling out. The scenario you've got now is as if this train had come in last and flipped the switches to straight and stop. And this engine here would be leaving the siding if it could. You can see it's trying to leave and not getting anywhere. Now, let's assume that engine, pretend that engine had actually left and gone. The straight branch of the siding in that case would be empty. So you'd have another train coming in the straight branch. It would come in back here and cross this track contact here. It'll flip the power to the curve part. You can see this engine died, and now this train, again, if it were allowed to go, this train would leave, and this curve branch would be vacated. And meanwhile, this switch is switched to curve back here. Now the third train that came in would come along and encounter a curve switch. It would come in this branch here and activate this track contact, which would throw the power back to the straight side. So now this train can leave. This branch will be empty. The next one that'll come in will go over this track contact and throw it back to the curve side. And again, to notice the power is on whichever direction this thing is, the arm of the switch motor is pointed toward. The arm is back toward me right now, and the power is on the curve side back toward me. If I push the arm over toward the straight branch, it shifts the power over toward the straight branch. So the power is on either one side or the other side, depending on which way this arm is set to. And make a mental note, please, that notice the power is either on one side or the other, assuming there's voltage on the track. One of these or the other one of these will be live. I'm saying this because later on when we discuss the next item, the automatic switching block that I'll discuss after these sidings, with the automatic switching block, which looks similar to this, we actually have the block circuitry combined with the switching circuitry, so you can have a case where neither track has power. Like I say, make a mental note with this unit that the power is always, it's either one side or the other side. So just make a mental note of that. One thing I almost forgot to demonstrate that I should demonstrate here is the effect of the rheostat on these on the voltage in these sidings. I've had the rheostat turned all the way forward, which gives it minimum resistance, which effectively this thing is acting like a wire. In other words, as I was demonstrating it a moment ago, this rheostat really wasn't doing anything because it was set to zero resistance, which meant power was passing through it just like it was a piece of wire. So what I'm going to do now is turn these engines back on and just vary the rheostat. And you can see when I turn the rheostat backward, it'll start adding resistance to this path, and the engines will slow down and be running at a reduced voltage. So you can see that the rheostat can be used to drop the voltages in those branches. And the rheostat acts equally on both legs, by the way. And what it does, just recapping what I said a moment earlier, the rheostat allows you to drop the voltage, so like when this engine starts, if this track is curved, it won't yank so hard on the cars and possibly yank them off the track. Then once it gets to the end of the block and hits the main line here, or in this leg over here, it'll get full track voltage and take off at normal speed.